So now there's the phase bode plot. Similarly, like your gain bode plot, the first thing first, you change your S equals to j omega. So this should come in the same step as your gain margin. Okay, your gain bode plot lah. Okay, so if you were to redo everything, you have this formula over here. Alright, I'll not go through the details. You can just head back to the videos and watch it out. Okay, so likewise you found that your frequency is actually 1 over 10 for your lead, and your lag is actually 10. Okay, so with this information, how do we find and how do we plot our phase bode plot? Okay, so I have this set up over here. What you do is actually, for the x-axis, is the exact same thing as your gain bode plot. Okay, except for your y, you change it to degrees, 90 degrees or whatever. Okay, so the first thing first, like what you did for your magnitude, okay, for your gain, individually you're gonna take piece by piece and then you just do up the phase angles. Okay, so in this case, the phase of gain is equals to k. Okay, the phase of gain of the k, this value 10, is actually 0. The reason why is because, okay, since the gain is actually 10, right? So if you remember, the phase angle is actually tangent inverse imaginary over real. So imaginary actually axis is actually 0. Okay, it's just a pure real number for gain. So anything divided by 0 is 0, and tangent inverse 0 is actually 0 degrees. Okay, so this is the first part you're gonna do for your phase. Now I'm gonna do for my lead. Okay, so for my lead, so as your phase of your lead, okay, of this dude over here, you're gonna have a tangent inverse imaginary, real equals to omega divided by, so imaginary over real, so imaginary is actually this one, okay, divided by your real is 1. Okay, you may wonder where's your j. J is just indicating that it's imaginary, so this is why for simplicity I didn't include the j. So now this is the problem. You may wonder, how do you want to find? Should I plot a series of omega, or should I do what? So I actually use the frequency of the cutoff frequency, so in order to make the tangent inverse 1, okay, so that I can actually find the, how it gradually goes up or goes down. So in this case, I use the cutoff frequency omega c1. So in this case, right, only this case, omega c1 over omega c1 is equals to 1. So this is why I have tangent inverse 1. So if I do that, I have 45 degrees. And then where my cutoff frequency is actually 1 over 10. Okay, so I've actually forgot to plot the phase of gain, because 0 degrees is just one straight line. Okay, the phase of the gain is just one straight line down. There's nothing much for me to draw, right? So as for the phase of the lead, it started off with at a cutoff frequency of 0.1, right? At this point, and it's growing in the 45 degrees per decade, right? So if it's going in the 45 degrees per decade, let me draw. So 1 decade. So this is like almost, as you can see, this is 45 degrees, right? So about 45 degrees per decade. So you should follow this about this line over here. So this is the, let's label. So this is lead 45 degrees. Okay, and then I'm not done yet. Okay, so this is actually wrong. Alright, why is it wrong? Okay, for the phase angle, okay, for phase plot, okay, when you're plotting, you're not plotting your cutoff frequency. Okay, you're plotting your cutoff frequency divided by 5. Okay, and therefore in this case, what you have is actually, because this is the fuck, yeah, I keep saying fuck off frequency. So it's 110 divided by 5. Alright, so 0, which is 0.1 divided by 5 lah. Okay, which is 0.02. Okay, so this is your cutoff frequency. Okay, your cutoff frequency should be at 0.02, right, which is somewhere over here lah. Okay, so what I'm gonna do is actually to move this graph. Okay, to this point. Never mind. Hold on a while. So when I moved over there, before that, I have to label 0.2 again. 0.2 cutoff frequency. Okay? But before I continue drawing the 45 degrees, I just realized something. Okay, instead of only calculating one angle, you're gonna calculate another angle. Okay, previously you calculated 45 degrees, right, when omega is equals to the cutoff frequency. Now, if omega is 0, okay, if omega is 0, so in another case, okay, so maybe I should write it down. I'll repeat again. So if you are talking about phase angle, right, the first thing you do is to locate the 0.2 omega cutoff frequency. So for a single cutoff frequency, okay, for a lead cutoff frequency in this case, you need two positions. The first one is 0.2 times the cutoff frequency. The next one is 5 times the cutoff frequency. Okay, so at 0.2 and 5 of the cutoff frequency is minus 1, right? So if it's 5 times, you're gonna have a point that is 0.5 over here, right? Okay, never mind. So refine this thing. Okay, what I do is that first of all, you have your omega frequency 1, right? You need to first plot out your 0.5 and 0.2 omega c and your 5 times omega c1 position. So if you do that, you have to first, because you are talking about x-axis, right? X equals to log omega. So this is the frequency. You have to logarithm the frequency itself. So if you were to, because you know that our car frequency at this point is 0.1, so we can just simply do that. So if I were to log 0.0.002, is it? Yeah, 0.2. I'll have approximately like minus 2.69. Okay, so it will be somewhere in the middle of the plot itself. Right, minus 2 point, so somewhere, minus 2.69. My fault. It's 0.1 times 0.2, you have 0.02. If I logarithm it, I should have minus 1.69. Okay, so minus 1.69 is somewhere over here. Okay, so that I can label this point as minus 1.69 or 0.2 omega c1. Okay, and then next I need to find the values of 5 times 0.1 of the cutoff frequency. So 0.5, which is minus 0.3, okay, somewhere over here. So at this point, this is minus 0.3 omega, okay, which is or 0.5 or 5 omega c1, right? So in between them, in between these 2 points, you will have a 45 degrees. Okay, you have a 45 degrees angle. Okay, I didn't. So this is your lead. Okay, omega c1. Alright. So I've plotted the lead. Okay, now I need to plot the lag. Okay, so phase of lag. So phase of lag, let's do it together. Okay, so we have tangent inverse imaginary over real equals to omega divided by omega c to the current frequency of the two divided by 1. Okay, this is simply because this is my imaginary axis, this is my real axis, right? And therefore, if you were to do that, what I need to do is actually the same thing. I need to calculate. So in this case, I don't believe you need to calculate this dude over here. Okay, this is sorry, cancel off. What I mean is you just leave the equation like that. If you want to calculate for the exact angle, then you can use this formula. Otherwise, when plotting, you can straight away plot the thing out using this phenomenon lah. So what I do is that in this case, I need to plot out omega c2, right? So let's isolate this dude. So omega c2, I need to have two different frequencies, 0.2 of the omega c2 and 5 times the omega c2, the kind of frequency. So we're talking about omega c2 is actually the leg, okay, the phase of the leg. Where the phase of the leg omega c2 is equals to 10. Okay, so 0.2 times 10 is actually 2. And then this is actually 10 times 1 is 50. So if I have to log 2 it, because this is x equals to log 2, right? I mean log omega. So if I were to do that, what I have is actually, I have a 0.3, okay, and then 1.698. Alright, so every time the 0.2, right, is always either minus 45 or 45 degrees. For lead, you have a plus 45 degrees. For lag, you have a minus 45 degrees. Okay, so in this case, I have these two coordinates. So what I can do is actually to plot out the 0.3 first. So 0.3, maybe I should use a different color now. So the 0.3 is somewhere over here, right? So 0.3, this is the 0.3, and then this is 0.2 omega c2, right? This is the position. And then the next one is actually the next position, which is 1.698, right? 1.69 is approximately about 1.7. So this is 1.7, and then or if it's 5 omega c2, right? So from this point to this point, you will have a negative 45 degrees, which is the lag system now, right? So what I can do is actually to also draw out that line. Yeah, approximately this is 90 degrees. So from 45, and then I'll have this line over here. Okay, and then I label it as a lag WC2. Okay, so this is the lag angle. Now last one is that we have the integrator, right? Integrator is simply anything you need to calculate. If you want 1 over s is equals to tangent, never mind, let's write it out. Imaginary over real is equals to imaginary actually is this is actually j omega lah. S equals to omega, right? So omega divided by 0 is equals to infinity, right? So tangent inverse infinity is equals to 90 degrees. Well, however, it is a denominator, it is a pole, you're going to have a minus. The integrator has a negative sign. So it's just a one straight line down. So this is why I have a minus 90 degrees all the way down. It should be at the same line, but I just want to define that there is a slightly green color line, overlapping it. Okay, so this is my integrator. So I've plotted out all the different elements, okay, of your transfer function, of your phase angle. So this is just a layout of your phase angle, okay. So it is similar to your just a layout for your magnitude gain. Okay, so next video I'll draw the actual phase plot, phase value plot. See you there.